know the layup, right? It's probably the first shot you ever learned. But what if I told you it's also one of the most incredible feats of engineering you'll see on a basketball court? Seriously. Today, we're going to break this thing down, not just as a sports move, but as a super elegant solution to a really tricky physics problem.
So what is that problem? Well, think about it. You've got this challenge of trajectory, timing, and force, and you have to pull it all off in like a split second. Oh, and yeah, there's someone actively trying to make you fail the whole time. It is way tougher than it looks. Okay, let's put on our engineering hats for a second. Here's the problem statement. You need to deliver a payload, that's the basketball, to a super precise target. Simple enough, right? Wrong. You're doing it at high speed, from all kinds of different angles, and you've got to navigate obstacles, like a 7-foot defender trying to launch your payload into the stands. So to solve a problem like that, players have basically created a standard blueprint. It's this foundational model that, when you get it right, gives you a super reliable solution. So let's go ahead and break down that fundamental design.
So here's the textbook definition from Basketball for Coaches. It sounds almost laughably simple, right? Dribble, take 2 steps, and just lay the ball in. But we all know the real magic, the genius, is buried in the details of how you execute that. This is our starting point, our baseline, the classic traditional overhand layup.
All right, so how does this blueprint actually work? Well, it's really a 6-step process, but it all flows together into one smooth, continuous motion. First up, you got to get your eyes up, lock onto your target on the backboard, and see what the defense is giving you. Then, you kick off the movement with a long, controlled step with your outside foot. That's to cover ground. Right after that, you explode up with a high jump off your inside foot to get that vertical lift. And the whole time, you got to be protecting the ball. The finish? It's all about that soft touch, that follow-through, guiding the ball off the backboard. And of course, the final step is practice, a lot of practice. That's what burns this whole complex sequence into pure muscle memory.
Okay, now we get to the really cool part. Let's look at the engineering behind the movement. I mean, why does this blueprint work so darn well? The answer, believe it or not, is in physics and a concept that's actually borrowed from material science.
So in the world of engineering, there's this thing called an anisotropic material. It's a fancy term for something that has different properties, like stiffness or strength, depending on which direction you push or pull on it. Think about a piece of wood. It's super strong along the grain, but try to bend it against the grain, it snaps way easier. Well, guess what? The human body is pretty much the ultimate anisotropic system. And this image here shows the idea perfectly. See those layers in that composite material? Just like that. Your body isn't equally strong or flexible in every direction. It's just not. Our muscles, our bones, our tendons, they're all lined up to be incredibly powerful along specific lines of force, or vectors. A perfect layup is literally designed to take maximum advantage of that.
And this is where it gets really interesting. We can actually connect a core engineering principle, something called transformation of axes, directly to an advanced basketball move. So look on the left. You see the physics diagram for how engineers figure out stress on an object that's been rotated. Now look at the right. That's a player doing the exact same thing with their body during a Eurostep. It's wild.
So, by planting their foot and explosively changing direction, a player is basically doing a real-time transformation of axes. This move creates what engineers call a coupling of forces. It's turning that forward momentum, that's the normal force, into side-to-side movement, or shearing motion. This, right here, is the biomechanical secret sauce that lets a player just glide around a defender who's committed to moving in a straight line. Which naturally brings us to the advanced designs. Okay, so if the standard layup is our basic blueprint, then all the variations you see are like specialized solutions, custom engineered to solve really specific problems the defense throws at you. They're not just for show, they are absolutely functional.
And man, there are a lot of variations in the design library. You've got the underhand layup, the finger roll, the floater, the off-foot layup, the Eurostep we just talked about, the reverse layup, even the power layup. Every single one is a different tool for a different job.
All right, let's run through a couple of quick scenarios. Problem number 1, you're driving to the hoop and there's a much taller defender just waiting under the basket ready to send your shot into the 3rd row. What's the engineered solution? The floater. It's genius, really. You release the ball a little earlier and put this high, soft arc on it. You're just changing the whole trajectory to go over their outstretched arms instead of trying to power through them. Simple, elegant, effective. Okay, next problem.
The defender has played perfect defense and completely cut off your direct line to the basket. Going straight is just not an option anymore. And the solution here, you guessed it, the Eurostep. We just broke down the physics, right? You use that transformation of axes to take that big sidestep, get around the defender, and boom, you just manufactured a brand new clean angle to the rim. Problem solved.
But of course, even the most perfect blueprint is useless if the execution is off. So it's time for some quality control. Let's look at the most common system failures, the mistakes everyone makes, and the fixes or system updates you need to install.
The biggest system failure, number one with a bullet, especially when you're starting out, is just rushing the whole thing. You try to go 100 miles an hour, and it just causes a total breakdown of the system. The fix is so simple. Slow down. Seriously. Start close to the hoop, get the mechanics down pat, and then you can start adding speed. Control is everything.
Okay, another huge one, taking off from way too far out. When you do that, you're forced to kind of push or throw the ball forward instead of laying it up softly, and that's why you get that hard brick off the backboard. So the fix is a little calibration update for your GPS. You want to time your steps so you're taking off about 2 to 3 feet from the hoop. That's the sweet spot for a soft, upward release. Now, this one is a small detail, but it makes a massive difference. A lot of players bring the ball across their body when they gather for the shot. That's a major security flaw. You're basically serving the ball up on a silver platter for the defender. The system update? Keep the ball on the same side of your body as your shooting hand. So if you're shooting a righty layup, keep the ball on your right hip. Lefty layup, left hip. It's a super simple change that gives you maximum ball security.
Ultimately, getting good at all these variations isn't just about having more moves, it's about strategic innovation. I love how Reddit user rPirateKing put it. They called it an offbeat layup which messes up the blocker's timing. That's perfect. It's a deliberate glitch in the rhythm that the defender is expecting. It's an advanced technique that totally exploits their brain's predictive timing. So there you have it. From the absolute fundamentals to some pretty advanced biomechanics, the layup is truly a masterclass in real-time, on-the-fly engineering. The basic blueprint is there for you. The advanced variations are your specialized tools. And the physics behind it all, that's universal. So you have the blueprint. The only real question left is, what are you going to build with it?